and they will.
Yeah, we'll wait for another couple of minutes. People are still joining.
So hi everyone, my name is Nitin. I'm the lecturer for this course. Hopefully you have seen I'm answering basically the forum question answers. Okay. So I am here for your semi-technical and non-technical doubts. Basically, very first doubt which I have encountered about the exam. So the exam will be fully optionals. It will be MCQ based. The question will be at around 50, and it will be 3 hour exams. There's a no without optional question will be available. Like all question will be optional. They have 4 MCQ. If you choose one of the correct options. And the second is uh, like any programming assignment in upcoming weeks. No. So basically, we are not going to teach you any programming concept. We will demonstrate the programming solution, but we won't teach programming. This is not that kind of course. And basically, we expect you should learn Python, MATLAB, or PyTorch, or Keras, TensorFlow, whatever suits you. So we are not going to teach programming, and we won't give any programming assignments. And the third is there's one more technical query. There's one thing, if there's any error in question in the assignment, so there's an NPTEL policy. Once the deadline will get over, then and only we fix the questions. So once it gets over, I mean, probably we'll exclude that question from the evaluation matrix, or because since the question have some issues, so we will exclude. We won't include in the final grading. So these are 3 major questions has been asked in the forum, and feel free to ask any question in the forum. I will try to answer as soon as possible. Thank you. Yes, Durga, over to you.
Yeah, thanks for that. So we'll get started with today's session. So before starting that, so if any one of you have any queries from the last week's or this week's session, you can just ask. If none, then we will proceed with the questions, and as we discussed in the last week, we'll also discuss the concepts that are relevant to those questions.
Excuse me, sir.
Yeah.
Sir, here I am for the past graduate one. So I don't know about what's going on or whatever course
Okay, so have you gone through the week 1 and week 2 lecture videos?
No, sir, I don't know. It is my past NPTEL course, and I don't
Okay.
know anything.
Okay. So maybe after you go through the videos, if you have any doubts, you can come up for the session and then we will discuss them.
Sir, how many assignments there is going?
One assignment per each week, and the course is for 12 weeks.
Okay, sir. Sir, what is the syllabus about?
Dear learners, please look into the course website
Yeah.
and everything is mentioned over there. And if you see the course list, all things have been mentioned by the NPTEL side.
If there are no specific questions, then maybe we'll get started with this week's. Like I'll have some questions for you so that you can solve them. Like we can solve them all, and then see how far we'll go. Yeah. Let's get started with the first question. So it would be better if one of you can actually pop in and then tell how you'll be solving them, so that we can have one discussion. So just to give the context, this week's assignment is mainly focused on probability theory. So we'll be discussing on like the basic fundamentals are all should already have been clear for you. So probability essentially tells you the likelihood of some particular event or some particular, in this case, an event. So the first question is essentially you have a wheel of fortune. Yeah. A wheel of fortune that is continuously calibrated from 0 to 1, so that the possible outcomes of an experiment consisting of a single spin will be numbers in the interval 0 to 1. Unlike the normal wheel where you have discrete sets, here you have a wheel which gives continuous numbers from 0 to 1. Assuming it to be an unbiased or a fair wheel, which also means to say that all outcomes are equally likely, that any number between 0 to 1 is equally likely, what would be the probability that what is the probability of the event considering a single element? So how do you construct the probability model for these kind of systems?
Uniform distribution.
Yes. So you can start with a uniform distribution. So what will be the probability for that? For a single element, if I want to say what will be the probability that your outcome is say 0.5?
0.
0. So if I want to have some finite number, how would I go about it?
Integrate over the span.
Integrate over the span of whatever interval I want. Say if my objective is to get the values in the interval 0.4 to 0.6, what would be the probability value in this interval?
1 by 5.
1 by 5. So essentially it's 0.6 minus 0.4. So to those of you who are not familiar with uniform distribution, so basically we have two different kinds of like we have continuous probability distributions and discrete probability distribution. The ones that we encounter usually in high schools are the discrete probabilities, where all your event space will eventually have some discrete elements. Unlike the say the sample example is tossing of a coin, where your outcomes are only two possible outcomes, heads and tails. So those are your discrete outcomes. That is one class of distributions. The other ones are continuous distributions, like the one presented in this problem, where you can have any real number. The outcome will be any real number. For such scenarios, we cannot actually identify the probability of any single event. Why is that? So maybe I can answer. You can answer the same question. So why did you say that the probability for one particular element is 0?
The area will be very small.
Area under. So okay, you are saying area. So what am I plotting? What is my x and y?
X will be a random variable. Y will be the probability.
X is your random variable. Okay, in this present question, what is x?
X is from 0 to 1.
X is from 0 to 1, so it is the number that comes out of your wheel. And what is the y?
F of x is 1.
Okay, but what is this y? What is this called?
PDF.
probability density function. In case of a uniform distribution, it turns out to be 1. Okay, so yeah, the next obvious question, say when the first question I asked you is what is the probability at 0.5. So how would I get probability from this PDF? Like as you said, we need to calculate the area to get the probability. So if I have a certain interval from 0.4 to 0.6, this area will give me the probability that x will lie between 0.4 and 0.6. And for a particular, if I give a single point, then there is no area because there is no width for that, and in those areas your probability turns out to be 0. This is fairly straightforward. Let's go to the next question.
I have just one doubt.
Yeah.
So when it says distribution, PDF distribution, and when we are saying the single element, that is why it is coming as 0.
Yes. Okay. Let's go to the next question, the second question. So you have two people and then they want to meet at a given place at a given time, but then any one of them can randomly be late by any time between 0 and 1 hour. So, and it is also given that if when Romeo arrives to the place, he'll wait for only 15 minutes and then he leaves. Only if Juliet comes in that particular 15 minutes, both of them will meet, otherwise they won't meet. So what is the probability that they'll meet? How do I go about solving such kind of problems? So first, the basics. So what is my probability model here? How would I construct my probability model? What are my random variables here? So like previously you told the wheel of fortune, the outcome is considered as x is your random variable. So what will be the random variable here?
The time.
The time. The delay will be your random variable. So there are two. So there are two things, one for the Romeo, one for the Juliet, and both of them, can I consider them to be uniform distribution?
Yes.
Yeah, so the delay is between 0 and 1 hour, so I am assuming a uniform distribution of 0 to 1, and Juliet is also from 0 to 1. So now the question tells you, if one of them comes, like Romeo can come at any point of time, and when he comes, he will wait for 15 more minutes. And if Juliet comes within those 15 minutes, he will stay, otherwise he will leave. So what is the probability that they will meet? How do I go about solving such kind of question? So as like the previous question, if you start from, say if I say rho r here, and this is my probability density function between 0 and 1 hour, and similarly you will have for Juliet as well. So can I solve from this? Like what we discussed from the last question is how do you get probability? You need to calculate some area. To determine probability, you need to calculate some area. Which area will I calculate? So if I say 15 minutes, it can be any 15 minutes, right? So it can be from 0 to 15, or it can be 1 to 16, or like there are several different combinations that are possible in this. So how do I know which area to calculate? Or am I missing something in this?
The area will depend on the time in which the first person.
Yes. So, but the time at which the first person arrives itself is a random number, right? Like, say if Romeo comes first, let's assume that Romeo comes first, he can come anytime between 0 and 1. So if Romeo comes at time r, and if r plus 15, or say like this is in hours, so 15 is 1 by 4. So if r plus 1 by 4, if I compare this with Juliet time, so should it be less than, greater than, equal to, what should be the case here?
Juliet should be between r and r plus 1 by 4.
Yes. So Juliet should be between r and r plus 1 by 4. So this physically it means that within the time of within 15 minutes, if the Juliet also comes, then they'll meet. So say if I were to plot, instead of in this way, if I were to plot say R versus A, so Juliet can be any time between 0 and 1, and Romeo can also be any time between 1 and 0. So now what we are saying is, this is 1 by 4 and this is 1 by 4. This is a straight line, like j equal to r plus 1 by 4 is a straight line, plus 1 by 4 is 1 is your slope and 1 by 4 is your intercept. So this comes out to be one straight line, and similarly it can be anywhere, any one of them can come first. So this could be the other one. So now if I can calculate the area in this region, like it should be less than r plus 1 by 4, and similarly other way it should be less than j plus 1 by 4. So this area, if I calculate, that should give me the probability, right? So you can calculate these coordinates, and then from there you can calculate the area. That should tell you what is the probability of it. Maybe we'll wait for a couple of minutes, so you can just tell me the value of the area, one of you. What are these points? What is the equation of this line?
Is that a slope and y equal to mx?
This is y equal to mx plus c.
R minus j is plus or minus
R minus j equal to, so okay, this line, is it plus 1 by 4 or minus 1 by 4?
minus
So if when your r equal to j is equal to 1 by 4, and the other line will be r minus j equal to plus 1 by 4. So what are these coordinates? Like what is this value? So when j equal to 1, your r will be 3 by 4, and this is a 3 by 4. So you can calculate the area of this, and similarly this is a 3 by 4, this is another 3 by 4. So total area is 1 minus 3 by 4 square. So that gives you the probability. Okay. Now let's go to the next question. So both of these questions are related to your continuous probability distributions. We are not going to discrete because I hope that you are already familiar with that. So this is something that you might not come across in your areas. So we're just going more over continuous distributions. So now let's go to the third one. This is a kind of a discrete one. So there are two design teams, say a conservative design team C and an innovative design team N, and they are asked to design a product within some specified duration. From past experience, we know that the probability that team C is successful is 2 by 3. So how do I get this probability? So over the last say 1 year, we calculated different instances that the projects were given to C. Out of them, how many are successful, and from there you got a probability of C. Similarly, for the second design team, you also got another probability that at least one team is successful is also given. So from these, the question is, if both of them are successful, then I would choose the one that is more innovative. So I will choose N if both of them are successful. The question now is, if only one is successful, what is the probability that it was designed by team N? So how do you solve this? Yeah, first thing, so is the question complete, or are there any missing information, or how is it? How do you start with it? Yeah, just to have some interaction. So why are we doing this probability anyway? Why do we need it, or do we need it?
We need it to analyze models.
Analyze models like? like what do you want to do out of your analysis? What is it that you're expecting out of your analysis?
To move toward the exact perfect answer.
Okay, so like last week when we were discussing on linear algebra, so if you have some system of equations, like you have some problem, you got some data, and then you formulate it as some system of equations with some unknowns and so and so, and then you solve the equations and then you find some values of your unknowns. That is one way that we have already dealt with in the last week. Like that is what your first week basically discusses about. So why is it that we want to do into probabilities? Like why is it just the linear algebra thing not sufficient? What is it that is extra that we are adding through probability?
To answer or make our move more probable, calculating the probability,
Okay.
whether it is a favorable answer within the subset.
Okay, so okay, let us take this particular example, this particular question here. So here you have two teams. So in this particular scenario, so you are saying that you want to use probability to like you are basically appreciating the fact that you do not know everything is successful always. So you need to come up with some probability values. So what does this first statement mean? The say in this particular scenario you have a team and then you gave some project to that team and then you don't know whether the team will be successful or not. So to quantify that, how are you quantifying that? To know whether a team will be successful or not, before actually giving a project to that particular team, you actually track their history and then see of the total number of projects, how many of the projects they were successful in. And then from there you will know, okay, if I give a project, there are so and so percentage chances that this project will be successful by this particular team. Okay, say suppose now in this particular question, if I tell you that probability that C is successful is 2/3, does it mean that C will be successful always? What do I infer from this statement? So out of every 3 projects, 2 projects are successful. So does that mean can I give the project to C or not? Will it answer that question? It's like some of you pointed out, like initially the first one pointed out that we want to do some analysis. So you did some analysis, you did some homework, you saw what the earlier projects that particular team has done, and then you finally came up with this one number that tells you that there is 67% chance that if you give a project to this particular team, they will successfully execute it. Now knowing this value, how will I go about? What will I do next? Okay, maybe you can ponder over and you can let me know once you have some ideas. Now coming back to the question. So the question here is, now I know that there is a successful design and there is exactly only, like out of these 2 teams, only one team has successfully given me the product. So what is the probability that it was designed by team N? So as and when I say probability, it means that it is not exactly done. So how do I calculate this particular probability? So where do I start? So first we start with like the formal approach, we start with some event. So your event, let's say C is your conservative, like I am declaring some random variable C, which is equal to either 1 or 0. 1 if conservative C team is successful, and this is otherwise. Similarly, define another random variable n, which can either take 1 or 0, depending on whether the team is successful or not. So now the question is, it is already given that probability that C equal to 1 is 2/3, n equals to 1 is given as 1/2, 50% and 67%. And what is the third part? The probability that at least one team is successful. So how do I write it mathematically? So at least one team is successful. Using this notation, how do I write that? Or even without notation, you can directly write it in a much simpler way. So you have C team, which can either win or lose. I mean, which can either produce a design or not. Which produces a design with probability 2 by 3, and it can fail with probability 1 over 3, because there are only two possibilities and the sum total should be equal to 1. And then once it is given to the next design, like you have another possibility for n, which could either be success or failure. If it is success or failure, and similarly you can have the two scenarios here, success and failure. So if both teams are successful, the question says that you will select the design produced by second team. So here you have n as your outcome. Now this is, say n has failed, then your C will be your outcome. In this scenario, C has failed and n succeeded, so you will have n as your outcome. In this, both the design teams failed, so you won't have any outcome at all. So now these are the probabilities. So first question, what is the probability of achieving this particular state? It's like, it also tells you that probability at least one of them is successful is either n equal to 1 or C equal to 1. At least one of them successful is 3 by 4. So if at least one of them is successful, is all three of these combined, is given as 3 over 4, which gives you that none of them is successful. This other leftover probability is 1 over 4. And what do I want now? If I know that only one design is produced, maybe I'll write the statement. Exactly one design is produced. Then what is the probability that it is produced by n? So out of these three instances, what are the instances where only one design is produced? So in this particular scenario, you have both C and N as successful. So two designs will be produced. So excluding that, in remaining both scenarios, there is only exactly one design that is produced. So if I want to know this probability, so if I just put names for this, say 1, 2, 3 and 4, the required probability as asked in the question should be given by 3. That's it, 3, or do I have to do something else? Okay, let us come back to the question of sample spaces. So what exactly is your sample space? Sample space is one that should encompass all your possible outcomes, right? So I am giving you a prior condition that only one design is produced. So now the probability of this 3 will actually have a sample space of all the possible outcomes. But I am telling you that only given that only one design is exactly produced, which means I have to restrict my sample space to only those where only one design is produced. And accordingly I have to kind of restrict this sample space, which means I have to divide this by that probability of that particular sample space. And what should come over in the sample space now? 2 and 3. So 2 and 3 will come now here. So accordingly this will give you the probability. So now how do I compute the values of 1, 2, 3 and 4? 4 I already know that it is 1 by 4 because all 3 combined is 3 by 4. There are only 4 possible outcomes, so total is 1. So 1 minus 3 by 4 will give you 1 over 4. So how do I calculate the other values? How do I calculate these probabilities? 3, 2 and 1. 3 and 2 and 1. Maybe I need to know 1 as well. Say if I want to calculate 1, how do I calculate that? Or will I be able to calculate, or is the information insufficient in the question? Or maybe I'll give you a couple of minutes so you can try that out and let me know. And to those of you who are not trying, maybe you can answer a simple question. So can I say the probability of 1 is equals 2 by 3 times 1 over 2? Like, can I just multiply them and say that it is equal to 1 by 3? So I'm just putting tick so that you will know that tick equals successful design and a cross is a design that is not successful. So what I'm saying here is you have a successful design produced by both C and N. So can I say that the probability that both C and N will be successful is 2 over 3 into 1 over 2? Yes or no? A simple answer. So is the question clear? Or maybe shall I'll put it slightly differently so that you can understand it much better. So I have two events, C and N. All I'm asking is, I want to calculate C intersection N, and I'm asking you the question whether this is equals probability of C times probability of N. When can I write this equation? When is this particular thing valid? Independent. So in the present question, are they independent? How do you know if they are? How will you know if they are independent or not? Outcomes are not affected. Like the outcomes of one event will not affect the outcomes of the other event. Okay. So in the present question, are they independent or not? So what does your data suggest? So based on data, I gave you some probability values here. So these are the values I got from the data after seeing their track records. So from this data, can you comment on whether they are independent or not? Yeah, just give me a second, I'll just show you the question. So we are discussing question number 3. So basically we have two design teams, C and N, so called conservative and some innovative design, and we know from their track record that the probability that if you give a project, C will be successful is 2 over 3 and N team will be successful is 1 over 2, and you also know that at least one of them will be successful is 3 by 4. Now the question is, can I consider C and N to be independent? They are independent. So how are you saying they are independent? So earlier you replied that outcomes are not affected. So is it what your data suggests? Success of one does not depend on other. Yeah, but how are you coming to that conclusion that one is not affecting the other? How can you come to that conclusion? Like, what is the basis to come to that conclusion? Like, can we prove it somehow? Or maybe from whatever data that is given in the question, or from whatever that you have told earlier. So we know that this particular equation is valid only when they are independent. So in the present case, probability of C intersection N should be given by, according to this formula, you have a 2 over 3 and 1 over 2, so that should give you 1 by 3. And I also know that probability of C is 2 by 3, N is given as 1 over 2, and I also know what is C union N, that is 3 by 4. So I can use the relation So if I use this relation and calculate C intersection N, what will I get? So one of you just calculate it immediately. What is the value I am getting here? Let me know if question is not clear or if you need any clarification in the concepts or anything, so then we will discuss those accordingly. So that it will be useful for to have this session. Yeah.
I'm getting 5 by 12. I'm not sure if it's correct.
Yeah, you are getting, no, it's 5 by 12. So this is essentially not equal to whatever we got previously, 1/3, which means you cannot consider those things as independent. That's what the data says. Yeah, I think the assignment 2 question number 10, yeah, it's been actually responded in the discussion forum as well, that there is something that has been wrong in that, and then we'll revise you after the deadline is over. Nitin has responded on that. And now coming back to our question, so now you know that these are not equal, which essentially means they are not independent, like you cannot consider them as independent. But one thing we also got is we also got this probability 5 by 12, that is 1. So we know this value as 1. And what is 2 and 3 combined? This should be fairly easy to evaluate. So all 3 combined is 3 by 4. So 2 and 3 combined should be 3 by 4 minus 5 by 12. That should give you around, say, 1/3. So can I, yeah, 1/3. So how will I get 2 or 3? Any one of these. If I get one of these, I would know the other. So how do I calculate 2 and 3? Basically 2 is that C is successful and N is a failure, or the other way around, C is a failure and N is a success. How will I get that? So what I am asking is, C is successful but N is a failure. I am just writing N complement, which means N is a failure. This or the other one around, C complement intersection N. So how can I calculate this? Do I need some more information to calculate this, or everything is available? Okay. So how do I know if the information is sufficient or not? Maybe let me reformulate the question. So to those of you who are already familiar with marginal distributions, or joint distribution, sorry. So I can create a joint distribution for this particular problem, yes or no? Can I create a joint distribution for this problem? Say I have C and N as 2 variables. N can take 2 values 1 and 0. C can take 2 values 1 and 0. I know for sure that C equal to 1, N equal to 1 has a probability of 5/12, but I do not know the other values. Let's say I have x, y, z. So I have 3 unknowns. Now I would require 3 equations to solve these. So do I have 3 equations? What are the other, do I have any constraints on this x, y, z? So if I were to calculate the probability from here, so this is x plus say 5/12 and this is y plus c. So what did we get here? 5 over 12. And this is y plus 5 over 12. And this is x plus c. The sum total should always be equal to 1, which gives you a one equation, x plus y plus c plus 5 over 12 equals 1. So I have one equation and three unknowns. I would not be able to solve it without another two equations. So what are the other two equations that I have? Do I have any other equation?
We know Z, right? Or, because we
Yes.
know the probability when both of them are 0.
Yes, so we have one more equation, that z equals to 1 by 4. So okay, now we have two equations and three unknowns. So we need one more equation to solve them. So what is that one more equation? That is, do we have it or do we not have another equation? So did we use all the information that we have? So the information that we have is probability that c equals to 1 is 2 by 3. So from this marginal distribution, how will I calculate probability of c equal to 1 in terms of x by z? So this is n and this is c. So how will I calculate the probability that c equal to 1 from this particular table, from this joint distribution table? So when c, yeah.
We could say x plus 5 by 12 is equal to 2 by 3.
So this is the probability that c equal to 1. So this is 2 by 3. And we also know probability that n equal to 1 is half. So what would be that in this particular table?
5 by 12 plus y.
Yes. So this will be equal to half. So now we have two more equations, that is x plus 5 by 12 equals 2 by 3 and y plus 5 by 12 equals 1 over 2. So if you calculate from this, what would be the value of x and y? This comes out to be around 1 by 12 and then
And x should be 1 by 4, I think.
1 by 4. Okay, so you have x, y and z. So you have 3. So maybe you can just substitute in this equation to check if the values match.
Yeah, they are.
Yeah, so now you have three equations, three unknowns, you solved all of them, so you got all these probabilities. Now coming back to our question, so what do we want here? So what is this particular one? So you have c equal to 1, n equal to 1, so this is 1 comma 1. And this is your c equal to 1, n equal to 0. This is c equal to 0, n equal to 1, and the last one is both of them being 0. Now the second one, so what we want is probability of 3 is n equal to 1 and c equal to 0. N equal to 1, c equal to 0 is y. We have a value of 1 over 12 by 1 over 12 plus probability of 2 is other one, c equal to 1 and n equal to 0. C equal to 1, n equal to 0 is x, and we know the value of x as 1 by 4. So this comes out to be
1 by 4, I think.
1 by 4. Okay. So it's clear, or there are any questions in this? Yeah, I guess there are no questions, so we'll go to the next question. Clear. Thank you. Yeah, now we'll go to Bayes' theorem. Okay, maybe you can go through the question. So there is an aircraft in a certain if an aircraft, there is a radar system and you want that to detect an aircraft. If an aircraft is present in certain area, the radar will detect its presence with probability 0.99, and if it were not there, then it will register with a probability of 0.1. So we assume that an aircraft is present with a probability of 0.5. What is the probability of a false alarm? A false alarm is when you have a false indication of aircraft present, which means like aircraft is present, but then aircraft is not present, but then you will your radar will tell that it is present. That is what you have a false alarm. A misdetection is opposite of that, where you have actually you really have an aircraft, but then your radar doesn't register it. So how will I calculate this? So like we are doing with all the problems, the first step we will start with defining some random variables, and then we will solve the problem. So here we have two quantities. One is the detection from the radar, second one is the presence of aircraft. So I can define two random variables, or maybe I'll just solve here. So I can define two random variables, say x, or let's say r and a. R is basically whether the radar will detect an aircraft or not. So if r equal to 1, the radar detects an aircraft. 0 is for otherwise. Similarly, I can define a is for the aircraft. If an aircraft is actually present, the value of that particular random variable will be 1. So if these are my random variables, so as per the question, what is this 0.99? How would I denote it? 0.9 is probability of something, so how would I denote that in terms of these random variables?
In between,
Yeah.
yes, somebody is asking question number 10 in assignment 2 is incorrect. Yes, we have rectified options are little bit biased, so we will update after the learning before. So please check or mark any of the nearest possible answers. Thank you. And one more thing, do you have any non-technical questions? Can you ask right now? Probably I want to be. If somebody have any doubt regarding, apart from what we are discussing, any doubt regarding exam pattern, assignment pattern, or evaluation methods, or even course content, etc., etc. If you have any questions. Okay. I will please know. So,
Yeah, in case if you do have any, you can just post on the discussion forum. He will be able to answer
thank you
them.
so much. Please enjoy the learning. One of the best friend is available here. Thank you.
Thank you, Nitin. Okay, let's get back to our question. So, yeah, I told you that there is some probability, some number here, 0.99. So, what is this number represent? So, how will I represent using these random variables that I defined just now?
P of r equal to 1 and a equal to 1
P of r equal to 1
and a equal to 1
and a equal to 1 is what? 0.99, 0.1, 0.05. Which one of these is that? 0.99. Okay. At this point, maybe it's the right time to discuss about conditional probability and other stuff. So, first question. So there are two things. You have something called, okay, can I write it in this way? So if I write it this way, is it valid or not? So given that a equal to 1, the probability that r equal to 1 is 0.9. If I say this, is it right or wrong? Which one of these two is right? So maybe you can just have a small poll. So one of you think the first one is right. Yeah, you can just put a tick or something. So you can just put raise a hand or something, so we can use that to just see how it goes off. So how many of you think the first one is right, or the first one is the one that we want? Okay, no one? Even the one who told this answer? Second one is right. Okay, why is it not the first one? Or when is the first one right then? first one is joint probability. Okay, the second one is conditional probability. Yeah, that is clear. My question essentially is to emphasize on the fact that from reading the statement or when you are given some scenario, how will you identify which one of these to use? So in the given question, it tells you that if an aircraft is present in a certain area, a radar will register its presence with a probability of 0.99. So should I consider joint probability or conditional probability?
Yeah, conditional, because if aircraft is present.
Yeah, so I already know that the aircraft is present, and then I'm telling you, okay, so when will you consider the other one? When will you consider a joint probability distribution? So even in this scenario, aircraft will be present, right? So what is the difference between this and this? If you want to understand intuitively, or it's like, what is the significance of it? When should I consider this and when should I consider that? You accept the fact that they are different. This becomes more and more important when we go into higher, go much deeper into the course where you will be dealing with different models. So sometimes you will be trying to model conditional distribution, and other times you will be trying to model the joint distribution. Like I gave you some values here, 0.9 and 0.1 so and so, but ideally you would be getting these values from the data. So you observe something, you collect data from something, and from that data you need to come up with these values. So basically you are trying to model these distributions. So which one of these distributions you model is something that is up your decision. So how do you know which one of them to use? Yeah, in this particular scenario, okay, it is clear that I told you that an aircraft is already present, which means say I am standing outside the observatory, and then I know when the, I would know, I'll get some signal on my phone that tells when the radar detects the presence, and I can directly see whether an aircraft is present. So I have already seen an aircraft, so I know that aircraft is present, and then I can see whether the radar is detecting it or not. So which means that say if I have seen 100 airplanes when I am standing outside the observatory, out of those 100 airplanes, how many times did the radar tick, or say did the radar detect it? That's what the conditional probability gives you. If that is what conditional probability, what is the other one? What does your joint probability distribution give you? What is your sample space for joint probability distribution? So difference mainly lies in your sample space. In this, it's basically only out of all the aircrafts you have seen, how many are detected. But in case of joint probability distribution, your sample space will be much wider. You wouldn't know whether an aircraft is present or not in the first instance. So your sample space will be much larger. Okay. Does that make any sense? Or maybe we'll go to the problem. Once you solve it, you'll understand it maybe. Okay. Now in this particular question, you have accepted that this is what is given in the question. So if it is not present, the radar falsely registers an aircraft presence with probability 0.1. If it is not present, in the sense A equal to 0, the radar will detect its presence, which means R equal to 1. This is given as 0.10, and we assume that an aircraft is present with probability 0.05. So the presence of an aircraft is A equal to 1 is given as 0.05. So using these values, how will I calculate the first part, the probability of false alarm? False alarm is like just as a question says, a false indication of aircraft presence. So even though aircraft is not there, your radar will detect its presence. So first, before actually doing any calculation, how would I write it in terms of these random variables? Conditional, joint, what should I write here? Okay, let's make it even simpler. Do I know whether an aircraft is actually present or not? I am sitting inside the observatory now. I do not know whether an aircraft is actually present or not. All I know is I can just see the radar, and from there I have to know whether there is a detection signal or not. If there is a detection signal, then what is that? That is a different scenario. The question now here is asking, what is the probability of a false identification of an aircraft presence? So what should I write here? Okay, one thing is clear, that there is something called false identification of aircraft presence. So there should be something called A equal to 0 and R equal to 1. But what should be there in between? Is it a conditional probability, joint distribution, or what should it be in between? Like, should I write it like this, or should I write it the other way, or should I just write like this. So we have 3 options now, or any other options that you have. Basically, false detection is you don't have an aircraft, but then your detector says that there is an aircraft. So these are the 3 possible scenarios. Yeah, which one?
It should be the first one, but I'm not sure. But that is already given. Then what is
Yes.
there to solve?
Okay. Okay, good point. So it's since it is already, so you can ask a question saying like I can just ask a question to test your understanding also. So you think it is first, but you are not sure just because it is already given in the question.
It's already given 0.10.
Okay. So no one votes for the second one? Second or third? Okay, we have one vote for the first one. Okay, let's understand this. So what does this particular statement mean is again like you don't have an aircraft, but your detector gives something. So this means you have a ground fact that you already know that an aircraft is not present, which is usually not the scenario. It's like you do not know if, so the question here asking is about your, say like you are sitting inside the observatory so that you cannot see what is happening outside. So you do not know whether an aircraft is actually present or not. So your sample space is not restricted to this particular possibility that say if there is another person, if say I and the one who answered, he is standing outside versus I'm sitting inside. When he is standing outside, he actually sees that there is no aircraft and then see the radar signal. That is what this particular option tells you. Now if I am sitting inside and I have seen a radar signal, but I do not know anything about this, that is the second option. And the third one is where you do not know anything about any, like you are not even inside or outside, you are just do not know anything about this. All you know is you just construct all these possible scenarios, and from there you just determine the probability of this. And this is what goes for the one who is designing this system. So he just designs so that this particular value is minimized. So does that make any sense, or are there any questions in this? So depending on who you are, your interpretation should change, and accordingly you should calculate as per your requirements. So if you are sitting inside the stationary and you know that you have seen some signal from the radar on your screen and it says that there is an aircraft, what is the probability that aircraft is not present? That is something that this particular quantity represents, which is not the one that is asked in the question. The question is about the false alarm of the particular system. That is your joint distribution, that you don't know anything about any radar or the aircrafts, but all you want to calculate is what is the probability that your radar will give 1 and at the same time your aircraft won't be present. Basically R equal to 1 intersection A equal to 0. That is what you call as a false alarm. So how do I calculate this? So this should be straightforward. How do I calculate this?
I think that should be the first term that you have written, that into the probability that k is equal to 0.
Yeah, coming from the definition, this is what you arrive at. So conditional distribution is defined as intersection defined over the subspace of that particular conditioned event. So this you can substitute the values and you can get a value here. So R equal to 1, A equal to 0 is 0.1 times probability that A equal to 0 is 1 minus 0.05. So this gives you the false alarm. Now what about the second question? What is the probability of missed detection? Means nothing registers even though an aircraft is present. So this should also be straightforward. So what I am asking is nothing registers, which means R equal to 0, but an aircraft is present. So your A equals to 1. So from previous definition, what can I write about this? I can write it in two ways. I can write either as R equal to 0 given A equal to 1 times probability of A equal to 1, or I can write this also as A equal to 1 given R equal to 0 times probability R equal to 0. Since I know only these values, I will go with the first formula. Okay, what is the probability of R equal to 0 given A equal to 1? What is this value here? Probability that A equal to 1 is something that is already given in the question, 0.05. What is the first term? What is the value of the first term?
0.01 I think.
So how did you come up with the value 0.01?
1 minus the 0.99 that is given.
Sure, so 1 minus this particular quantity. So R can only take two values given A equal to 1. So one of them is 0.99, so the other one should be 0.01. So 1 minus 0.99. So this should give you the probability of misdetection. So are there any questions in this particular problem, or we can go to the next one? I just kept a few problems on Bayes theorem so that you will get comfortable with it. We will be using this in the course later, maybe in the next week or next to next week as well. Not these problems exactly, but yeah, thank you. Let's go to the next problem. So basically you are in a chess tournament, and then you know that there is a probability of 0.3 of winning against like there are three different types of people, three different types of competitors you are going to face in the tournament. So they are just calling them type 1, type 2 and type 3, and these are the probabilities given that you will win against them. So again, the first question that I would ask you, say I will define three random variables, type 1, type 2 and type 3, and I also have another random variable, say W, that the probability that I will win, like this W will be 1 if I win or 0 if I will lose. So what is 0.3 now? 0.3 is basically the probability of winning your game against half the players, call them type 1. So what is it? So comma, like is it a joint distribution or is it a conditional distribution? Which one of it is? Which one of these two is your 0.3? Conditional. Okay, why not this?
It's the condition of winning against type 1 player.
Yeah, so basically you already know that they are type 1, and only if you play against these half the players, out of say 10 matches, you will only match 3 out of these only 10 players in this type 1, 10 tournaments with type 1 people. Okay, if we do the same for all of the other ones, so similarly you have given T2 and given T3, what is the probability of winning? So this should be straightforward. How will I calculate this probability? So basically you are given the values probability of winning given T1, sorry, this is given, given T2 is also given. All these three values are given. I want to calculate, and what else? How do I calculate probability of winning? Yeah, this should be straightforward. Use the total to, yeah. Someone is able to say something?
I think it would be like summing up all of these three, like multiplying them with their like probability of playing with T1 into the probability of winning
Given that T1, so T2 and so on. Yeah, that's it. So how do you calculate probability of, like I already given these values, so what is the probability of Ti or T1, T2 or something? How do I know that? How do I get that probability?
I guess since they are chosen randomly,
Hmm.
if it's half, so it would be 0.5.
Exactly. So they are chosen randomly, so the probability of T1 will be exactly the proportion of the type T1, that is half. And similarly probability for T2 will be 1/4, and similarly for T3 is also 1/4. If you just substitute these values, you can calculate the probability of winning. So the second one is applying Bayes theorem. So this should also be straightforward. So assuming that you have won, which means you already won, what is the probability of opponent being of type 1? So this comes out mathematically saying you already have won. So what is the probability that you have won against team 1? So if you apply the Bayes theorem, so what would that be?
The first term that we will find, probability of playing against T1 multiplied by probability of winning against given T1, that divided by the answer of the first part. I think that should be the
Probability of winning, total probability of winning.
yeah.
So basically you are restricting to the sample space of your only your wins, and out of them you are calculating with respect to T1. How many of them are won against T1? that is what this comes out to be. You can just substitute the values and you can find the calculate. Like maybe you can calculate and tell me an answer, or you can do it later. Okay, maybe it's all 5 questions, so maybe I'll pause for some time. So if you have any other questions, we can discuss for now. If you don't have any, then we can go for the next questions. It's like 1 hour passed into the session, so maybe I'll take a pause. So if you have some questions, you can ask. Other than what we are discussing now, if you have anything other than this, or any queries that you have when you are watching the videos, the recorded sessions, like week 1 and week 2. We'll discuss week 3 in the next week. So in week 1 and 2. Maybe I'll pause for 5 minutes, so you can just go through your notes, and if you have any questions, we will take them.
Just a general query, I think this session has been recorded. Where do I get the recording?
In your course, at the bottom you have an option to choose problem solving sessions. If you click on that, you will be redirected to one Google Sheet where you can get the YouTube links for all the recorded sessions. This like we will be having 3 sessions, I guess, 3 live sessions, so all the 3 will be available in that sheet, Google Sheet. That is there in your course panel on the left side, where you have week 1, week 3 lectures. At the bottom you will have problem solving session. You can access there. Okay. Please elaborate how P of T1 equals to half. Okay, so the question here tells you that as he said previously, so in a tournament you do not know, like you can choose any of your opponents randomly. In that scenario, it is out of say 100 people, you know that half of them, it's given in the question that half of them are type 1. So if you have 50 people of type 1 out of 100 people, then the probability that you will face against type 1 is proportional to it. So you have it's like, since all of them are equally probable, it's like your toss problem. So you can either get heads and tails. So what is the probability of getting heads is like 1 over 2. Like there are 2 possible outcomes, and out of them 1 is full. Yeah. Any other questions on the recorded sessions, or like when you go through the lecture you have any questions, or okay, if there are none, then maybe we can go to the next question. The next one is again fairly straightforward question. So we have a 4-sided die, which basically means you can only get 1, 2, 3 and 4. If the result is either 1 or 2, you just roll it again, otherwise you just stop. What is the probability that the sum total of our rolls is at least 4? It is just more of a what you call counting approach. You just count the total number of possibilities, and then from there you have your sample space is total number of outcomes. Out of them, how many are desirable by the total sample space will give you the probability. So it's just constructing that counting. So how do I construct it? So when I roll a die, so initially I don't have anything, I can get one of these 4 possible outcomes. If I get 3 or 4, I'll stop, otherwise I'll roll once again. So if I roll the second time, again I can get one of these options. So now the question is, what is the probability that the sum total of our rows is at least 4? So what are the this is where you have sum total of 4. Here you have 2 plus 4 6, 2 plus 3 5, 2 plus 2 4. 2 plus 1 is 3. Your sum total is not equal is not 4. So we exclude this. So you have 1 3. That's it. So whatever are the ticks ones are the ones that you have by sum total of 4. So how do I calculate the probabilities? What is the probability of getting 4 in the first row? Straightforward. You have 4 outcomes. All of them are equally probable. So this is straightforward. 1 by 4. So now coming to here, what is the probability of getting 4 in the second row, and 2 in the first row?
They should be independent, so just product like 1 by 4 to 1 by 4.
Yeah, so this is where your independence comes. So when you have independent events, probability that both of them are happening is equal to the you just multiply product of both of them. So you have a probability of 1 over 4 times 1 over 4, which is 1 over 16. Similarly, this is 1 over 16. This is a 1 over 16. Same everywhere else. So if you sum up all of them, you will get the total probability. So that is straightforward. Okay. Yeah. Now let us take this question. So there is some particular student who is attending a class, and at the end of each week she can either be up to date or she may have fallen behind. If in a given week she is up to date, the probability that she will be up to date in the next week is 0.8 or fall behind is 0.2. If she is behind in a given week, say if she is behind in week 1, then the probability that she will be up to date in the next week is 0.6, and she will be behind in the next week is also is 0.4. By default, anyone will be up to date by week 1 when the class is starting. So what is the probability that she is up to date after 3 weeks? How do I solve this? So say just as before, so we will define two random variables, u for update, I is for the ith week. If ui is basically the event that she is up to date, and b, say I, is that she is fallen behind for that particular ith week. So what are these probabilities? What is 0.8? Is the probability that she will be up to date in the next week, given the fact that she is already up to date in the given week. So probability of ui plus 1 given ui is given as 0.8, and given that she is up to date in the present week, the probability that she will not be up to date in the next week is 0.2. Similarly, the other ones, probability that she will lag behind in the next week, given that she is lagging already in the present week, is given as 0.4, and probability that she will be up to date in the next week, given she is lagging behind in the present week, is 0.6. And I also know the present initially for week 1, the probability that she is, say before week 1, that is when the classes start, so that is 0th week, week 0, is 1, that she is always up to date. So I am just writing 1. We don't have p0, b, probability that b equal to 0 is 0. So how will I calculate the probability that she is up to date after 3 weeks? Probability that she is up to date after 3 weeks is probability of u equal to 3. How do I calculate that?
I guess it will be probability of u3 given u2 into probability of u2. So for that we have to find u2 also later, and similarly plus there will be one more term.
What is it?
Probability of u3 given v2, and then into multiply by probability of v2.
Yeah, so basically you need to know information about b2 and then you put those things here. That's it, or do you have anything else? Yeah, so basically you have only two possibilities. You can either be up to date in the second week or you can fall behind in the second week. So you just have two spaces and then you have two terms, and so that's what you get. But to do this, you need to know the value of u2 and b2. Is again the same thing, so you just write another one times p of u1 you can solve it this way. So you can iterate from starting from probability. Again you can write another equation from p of u1 this is where you will stop. So basically probability of u1 given u0 times probability of u0. The second one will be basically 0 because probability of b0 is 0. So you know this value, you can calculate, find the value of p of u1. P of b1 is 1 minus p of u1. So from there you can get this, you can substitute here and you can substitute here, you can calculate this way. Or say if you want to do it, if you want to implement it in a computer, you can write a loop to iterate and then solve it, or you can also use matrices to solve this. So if I were to represent using matrices, say if I write this as a matrix, as a vector, say the probability of update and behind, both of them as in one vector, initially it's 1 and 0. So what will be the value of p of u1 and p of b1? So if I were to write it in a matrix form, what will be this transformation matrix? Like we call something like, basically when you do matrix multiplication, that is essentially some transformation. So you have an initial one p of u0 b0 and I want to get u1 and b1. So what will be the transformation matrix here? So seeing from these equations, can you fill these up, fill these values? So I want to know what the values that come here. So that I will call this matrix as transformation matrix A. So this transformation matrix will remain the same. So when you want to go from stage 0 to 1, you multiply with A on 0. When you want to go to 2, you multiply another time. If you want to 3, you multiply another time. So after 3 weeks, if you want to find the what are the final probabilities, you just do A cube times 1 and 0. If you want to get after 20 weeks, you just do A power 20 times 1 0. So that is clear. The only question is, how do we know, like do we know this value? Do we know this matrix A? What are the values of this matrix coefficient, the values, the elements inside the matrix? So seeing these equations, you will be able to fill these values.
From the equation we can tell it will be like
Yes.
u1 given u0.
Yeah, so what is that value? u1 given u0?
That should be the top left one.
0.8.
Yeah.
And what is this? This is, the first one is u1 given u0. So basically you are seeing this element and this element. So the second one should be u1 and b0. What is u1 and b0?
0.6, right?
0.6.
Yeah.
u1 and b0 is this, so that is 0.6. And the other ones should, like the sum total should be 1, so you'll have a 0.2 and 0.4. Now that you know the matrix, you can compute a square, a power, whatever weak you want, you can just do a power of it and then you will be able to calculate the resulting probabilities when you multiply with 1 and 0, because the initial one is 1 and 0. Yeah, so I hope this is clear. Yeah, now before going on to the next question, I just want to put up, so how many of you are already familiar with say expectation, covariance, variance and stuff like this? I hope it's not first time for you, or there anyone for whom, like, do I have to briefly say what these are? Like you already know the formula, so you can calculate it. If you do not, then maybe we'll see. So the question is on expectation. I haven't put questions on covariance and variance, because if you're good with expectations, then it's just a different thing. Instead of expected value of x, you'll have slightly different formula for covariance and variance. Let's calculate expected value of x. So what is the question here is, you have n people, all of them throw their hats in some bucket and then they randomly pick one hat at a random, they randomly pick one hat. What is the expected value of x, where x is basically the number of people that get back their own hat. So how do I calculate expected value of x? Okay, first stick to the basics. So what is your formula for expected value of x? Say you have, okay, before even coming to that, so is this a discrete probability distribution or a continuous probability distribution? Which one is it going to be? X, the value of x.
Should be discrete because the number of hats
has to be some natural number, or say whole number, so it should be a discrete random variable. So for discrete random variable, what is the formula for expected value?
summation of x into the probability of that x.
summation of x into probability of x. Okay, so what is the probability here for x? So if there are n people, so what is the probability that they get back their own hat? So if there is one person, one individual inside that n people, what is the probability that he'll get back his own hat? For any particular individual, the probability that he'll get his own hat is just 1 out of n, right? There is only one his hat. So out of n hats, the probability that he'll get his hat is just 1 out of your sample space is n. So it is 1 over n. And this is okay. Another question before going to the next step. So can I consider two of them to be independent or not? So say I have person 1, person 2 will have the same probability, person 3 will also have some probability. So I can have so many persons. So can I consider all of them to be independent, or does it not matter? Not sure? Okay. Okay. So for this particular question, so okay, if you are not sure about, for this particular question, how do I calculate expected value? Maybe we'll write somewhere else. Not independent, because for second person total hat will be n minus 1. Okay. So if for the second person, if the total hats is n minus 1, so how does that, okay, how did you come to the conclusion that it is not independent? Okay, say let us say P1, P2, so on you have Pn. This each one of them, like if you pick any one of them, their probability is 1 over n, because you have n hats and the probability that he'll pick his own hat is 1 over n. Okay, okay, I got your point. So basically you are, okay, I should have phrased the question slightly different. So it's like when you throw all these hats inside that, all of them pick the hats at the same time. It's not like one of them picks and whatever is left, second one comes and picks. It's not in that way. So all of them can randomly choose and then just pick it. It's like kind of replaceable kind of thing. It's not like once you remove it, it's not available for the other ones or something like that. So you just have to choose. Yeah, I should have mentioned it in the question. Okay, now with that information, it should be easy now. Okay, maybe I'll add that question and then upload it. I'll make the change and then upload it. So okay, so if you are given that fact, then can you calculate the expected value? So each one of them has the same probability and there are n people, so expected value will be okay. So your question is not clear, or do you have any challenges with this? So what is your expected value of x? You have to just take summation over all possible values of x times probability that particular x value is that x equals to that particular value of xi. Alternatively, if I define this as if I define another random variable, say y, which is equal to 1 or 0, where 1 is basically when, say y is yi, where I is for the ith person, equal to 1 if he gets his own hat, and 0 otherwise. So now if I define x as summation of yi, so if there are if y equal to 1 is for out of n people, if 5 people have y equal to 1, then x will be equal to 5, right? So if I define this new random variable, then if x will be summation of yi, this should give me total number of people, right, who got their own hats. Sorry, total people who will get their own hats. Now given the fact that it is replaceable, that if you have agreed on that, what is the probability that yi equal to 1? 1 over n, and yi equal to 0 is 1 minus 1 over n. If I have x as sigma x, sigma yi, what is expected value of x? How do I calculate this now? So I've gone through some of the properties of expectation and covariance. So you might have come across this where you have two random variables a and b. Expected value of a plus b is, can I write this as this? Yes. Does a and b have to be independent for me to write this? Yes. Okay. Do we need a and b to be independent to really write this? Okay, let's come to that. So if a is some random variable and b is some random variable, expected value of a plus b is basically summation of a plus bi times probability that a plus bi equals so and so. And then how do I solve this? Okay, we'll get to that in the next question. I think the next question is on joint probability distribution. Then we'll get to that. Okay, for now let's assume that in this particular scenario we already know that they are independent. So this I can write as summation of expected value of yi. What is expected value of yi? So I equal to 1 to n. What is expected value of yi? If my yi is this particular random variable with this distribution, what is the value of expected value of yi? You can have 1 with probability 1 by n. You can have 0 with probability 1 minus 1 by n. So this gives me a value of 1 over n. So this comes out to be sigma equal to 1 to n. You have 1 over n. So this is basically n into 1 by n. So this equals to 1. So the expected value of total number of people that can get their own hat, that will get their own hats, is 1. So there is only one person that is expected to get his own hat. What do I make out of that statement? Like, okay, why are we calculating this expected value anyway? Will this be of any help in, like, have you come across any situation or scenario where you have used expected value of x? Maybe one example. Not this one, any other one. Expected return out of a stock. Okay, very interesting. So okay, so out of a stock, so why are you considering stock as a random variable and not some okay, you already assumed that it is a random variable. Okay, so how do you calculate the probability there? Like, the formula is clear here. So to calculate expected value, you need to know two things. One is the value of that particular stock. Second is the probability that the value of the stock will be that particular value. So how do you go about calculating these probabilities? Or like, where do you get these probabilities from? Okay, maybe that is something that you will appreciate much better once you complete the course. Yeah, but just to highlight the fact that how once you are given the probabilities, it is much easier to compute the values of expected value. The challenge now is to compute these probabilities, to get these probabilities directly from the data. That is what we will be trying to do maybe at some point of the course where we'll be trying to get these probability distributions. Now let's get back to the next question. So there is some Professor A who often has her facts wrong and answers each of her students' questions incorrectly with probability 1/4 independent of other questions. In each lecture, she can be asked either 0, 1 or 2 questions, all of them with equal probability. X and Y with the number of questions May is asked and the number of questions she answers wrong in a given lecture. So basically she can ask either 0, she could be asked either 0, 1 or 2 questions, and she can answer either 1 or all 1, 0, 1 or 2. Like basically she can answer all of them wrong, or 1 question wrong, or 2 questions wrong. Now I want you to construct the probability mass function or the joint probability distribution since it is a discrete variable, it's a probability mass function, and from there you can calculate all the joint probabilities for all combinations of X and Y. Using this joint PMF, compute the probability that at least one of our answers is wrong. So this is a very straightforward question. So basically I have two random variables X and Y. So if I were to construct the joint probability table, Y can take values of 0, 1 and 2. X can also take values of 0, 1 and 2. Okay. So we'll quickly complete this. What is the probability that both X and Y are 0? What is X? X is number of questions asked. So I'll just write asked. Y is basically the number of questions that she answered wrong. So what is the probability that both of them are 0? Straightforward, right? What is the probability that X equal to 0 and Y equal to 0? How do I calculate this? Can I just write this? Asking the same question again. Are they independent? So it's already provided in the question, so you don't have to think much. So they are independent. So you can just write this formula, and then what is the probability that X equal to 0? And probability that Y equal to, sorry?
1/3.
1/3 times? So the probability that the answer 1/3 times 1/4. Okay, so maybe we'll take another number. So this is a fairly straightforward one. So all of them will be identical, or out of this maybe you can pick one. So what will be this particular value? Okay, 1 second. Before actually going there, let me put this again. So how did you come up with this 1/4 here?
Should be 0.
Yeah. So basically, if there are no questions asked, there is no probability of being 0. So it should be 0. So now what about the, okay, let's go another one. So maybe say this one. What is the probability that she will be asked one question and she will answer that wrong? So the probability that she'll ask one question is 1/3. So this is what you have been saying previously. And if she was asked one question, the probability that one question can go wrong is 1/4. This is straightforward. So maybe we should take another one. So let's say we'll take this one. So maybe you can calculate and tell me this. What is the probability that she will be asked one question? This is again straightforward, but she will answer two of them wrong. Can this happen?
0 again.
Yeah, this is straightforward. So maybe we should take this one the other way. The probability that she will be asked two questions and one of them she will be telling wrong. What is this? This particular value? Basically, she was asked two questions, and then what is the probability that she'll answer one of them wrong? all of them being 0. So basically there are two questions that are asked. She can either tell the first question wrong or the second question as wrong. So how do I calculate the probability for this scenario and this scenario? Like once I calculate this and this, I can sum up both of them to get the total probability. So what is the probability of happening in the first case? One by three is the probability that the first question is asked. And okay, so why 3 by 4?
Answering
Okay, the probability that she answers incorrectly is 1 by 4. So are you telling for the second one? So basically she has to be asked a question and then she has to answer correctly the first question, which is 3 by 4. And then should I put a dot or a plus here? Like she has to be asked a second question, so you need to have another 1 by 3. So should I put plus 1 by 3 times, she has to answer the second question incorrectly, which is 1 by 4. That is clear, but should I put a plus here or should I put a dot 1 by 3 times 1 by 4? So which one of them do you think?
asking two questions is 1 by
The probability of asking 0, 1 or 2 questions, like basically the probability of asking any one of the questions is 1 by 3. Yes, all of them are equally likely. She can ask one, she can be asked one.
1 by 3.
Yes.
3 by 4 into 1 by 4.
1 by 3 is the probability that she will be asked 2 questions. The first one she should be answering incorrectly, and plus or dot.
Into multiply.
Yeah, so dot. The second one she should be answering incorrectly, so that should be 1 by 4. So this will give you the case that of this particular one. If you want the first scenario, you need to be having the first one she should answer incorrectly and the second one she should answer correctly. So what should I do for these both answers? Should I sum them up or product? Which one should I do? Sum them up. So you have 2 by 3 times 3 by 4 times 1 by 4. That should give you 1 over 8. Maybe you can calculate the other ones. The last one is again straightforward. So if she was asked 2 questions, and what is the probability that all of them are wrong? So the probability of asking 2 questions is 1 over 3, and she should answer both of them wrong. Is 1 by 4 and 1 by 4. This one is also straightforward. The probability of asking 2 questions and answering both of them correctly is 3 by 4, 3 by 4. So okay, let's write.
So here it doesn't happen that the sum of the probabilities in a column will come to be 1.
Why do you think it won't happen?
Um,
Okay, it didn't happen. Sorry.
yeah,
No, it should happen, right? Because those are the only possible instances. But sum of columns, in the sense you need to sum up all of these values. Whatever values you get here, you sum up over here.
yeah.
Similarly, you get a sum here and then you add them up. Then you should get a 1 here. That you will have to check later.
Okay.
So what is the value we have here previously? I think it's 1 over 8, right? So maybe I'll write 6 over 48. And this is 1 over 12, so maybe I'll write 4 over 48. 6, 11, 20, and then whatever we have left. So what is the probability of the other one? So we are missing something. So probability of asking one question and then she answers that correctly. Asking one question times answering that correctly is 3 by 4. I think we missed something here. The probability of asking one question and she answering that one question incorrectly. Okay. So does this add up to 1? No, right? So which one of them is wrong here?
Yeah, I think it's not adding up to 1. I guess the 0, 0, 1 is wrong. The one where we have taken x equal to 0 and probably because the 1 by 3 is correct, but then it will not be multiplied by 0. I think.
So basically, if she was not asked any questions, the probability of she answering any of them incorrectly is also 1. So should I take one? Should I take it as 1?
I think it should be 1. I'm not sure. I think.
Okay. So if you take it as a 1, so what do we have then? We'll have this as 16 over 48. So what would that give us? Yeah, I think now it is summing up to 1.
Yes, now it's coming.
Yeah. So now maybe you can check all these values. So we have 16 over 48, 16 over 48, 9 plus 6 plus 1 is 16 over 48. So this comes up to 1. Similarly, the other one. (28) and 9 is 37. Yeah. Now, given these probabilities, like now we have the joint PMF. So the next question is compute the probability that at least one of our answer is wrong. At least one of our answer is wrong in the sense either 1 or 2. So what is the probability that at least one of our answers is wrong? You have to just sum up these two values and you will get that probability as 11 over 48. That is clear, right? That is straightforward.
Yes.
Yeah. Now coming to the last question. So message is transmitted by a computer in Boston through a data network or destined for New York with a probability 0.5. So there is Boston, and from there you have New York and then San Francisco. The probability that if you send a message from Boston, it will go to New York is 0.5. Okay, and there is Chicago as well. So let's write 3 places. For place 1 it is 0.5, Chicago it is 0.2, and for the other one is 0.2. Sorry, this is 0.3 and 0.2. The transit time x of a message is random. So basically the time taken from here to here, these are all random variables and they are calling it as x. So let us put a subscript to denote the location destination xc and xs. Its mean is 0.05 seconds. So I already know what is expected value of x for different scenarios. If it is New York, it is 0.05. If it is a second one, the value is given as 0.1, I guess, yeah, 0.1. And for the third scenario, it will be 0.3. So given these values, the question is what is the expected value of x? So how will I calculate expected value of x? Ideally we would be doing, it's like if you go as per the formula, expected value of x is given by summation of x times probability that particular x is so and so. But here we have 3 different scenarios. So x could either be to n, c or s. So to calculate that, we extend the same formula. So it goes as expected value of xn times probability that it will be xn plus This is something that you will be using often, maybe not now, later. So when you have like when you want to find the expected value of some particular random variable, but you know the probabilities that this random variable can possibly take, and also the expected values for those particular scenarios, then you just take in this, like basically it's like you want to find a mean for two values, but then you are giving some weightages for them. So these are kind of your weight means, the weightage that you give to for this particular message.
The probability acts like the
Weightage, yes. So here the values are given, so you have to just substitute them, so you will get the final answer. So we have 0.05 times, so xn is 0.5, similarly the other ones 0.1 times 0.3, and then the last one is 0.3 times 0.2. So if you just sum over them, you will get the expected value of x, the total time that it can take for any message that is being transmitted from Boston. This is clear. Okay, so I am done with the questions that I have for this week. So we have another 10 to 15 minutes left, so if you have any queries, you can ask. If you have none, you are free to leave. So I'll keep the forum open so that there are still people joining, so if they have questions, I can take them.
Do you have any good resource so that I can get acquainted with this, because I have very least idea about all this. I was able to answer questions.
The references were provided in the course for Christopher Bishop, the pattern recognition by Christopher Bishop. You can get the book in the course website itself. All these particular problems, only as far as probability is concerned, I have taken from a book on Introduction to Probability by Beth Sekas. This is a probability textbook. You wouldn't be needing all the details that are there in this. The one by pattern recognition by Bishop should be sufficient for this particular course.
Yes, thank you.
Yeah, I think it's Christoph Bishop. I'm not sure about the spelling, but you can check it in the website. Just to confirm in question number 8, the conclusion from the expectation value would be that average only one person will get his ad back. Yes. Yes, that's the conclusion from that question. Like to those of, I think Dhruv has asked this question. So if you're already familiar with say binomial distribution, are you familiar with binomial distribution?
Yes.
Yes. So, or okay, maybe easier one. Let's take an easier one. Okay, binomial or the easier one as a Bernoulli distribution. You can even take Bernoulli distribution where you just have two possible outcomes. X can only take two possible values, 1 or 0, with probability p and 1 minus p. So if your x is a Bernoulli random variable, and if you define a new variable y as say if this is xi, x1 plus x2 plus so on, this is what we have done in that particular problem up to n. If this is a Bernoulli random variable, this is going to be your if this is your summation of all these Bernoulli random variables, the expected value of y is simply n times p, right? This is something you might have come across.
Yeah.
So this is what we have done in that problem. That's it's slightly changed. That's it. So it only means that if your probability is too low, then you need to have to get an average value, you need to at least have that many instances. You need to take that many samples to get at least one value. Since the probability is 1 over n, you need at least n people to get on an average to get 1%. So both of them scale inversely. So you have a limiting case. Yeah, since you are already familiar with Bernoulli, so you should also be familiar with the next one, the Poisson distribution, where you have a limiting case for that.
Yeah.
So it goes on from there. Okay. Yeah, we have 10 more minutes left. I'll keep the forum open for questions. Can you please explain true positive, true negative, false positive, false negative with example? Example in question 10 of assignment 2. Okay. Okay. Were you able to solve the question? Because there is actually some problem with the question, and it was announced during the earlier part of this session that they're going to revise the question.
Actually, my main concern is to like I have not very clear explanation about true positives and true negatives.
Okay, okay, what are true positives and true negatives?
Yeah.
Okay, let's take one example, not that particular question, so the one that we discussed today. So if you see question number 4, so if you take this particular question, question number 4, you basically have a radar system and you have an aircraft. So the idea here is your radar has to detect an aircraft. Now there are different scenarios. So so basically saying your radar can either give you 1 or 0. If it is giving 1, it means the radar has detected something. 0 is when it doesn't detect anything. Similarly, you can actually have an aircraft. If an aircraft is actually present, I call it 1. If it is not present, I call it as 0. Now here comes like the aircraft can actually be present and then your radar can detect it. So basically this is your actual ground truth and these are your results. So in case of a true positive, you have a ground truth and then whatever detection mechanism you have used, it has detected it correctly. So it's like you have an aircraft and then your radar also detected that aircraft is present. This is what you call a true positive. Okay. Now comes the other terms likely. So the second one is like you really have something but then your radar is not able to detect it. So it's a true negative. And similarly the other one, false positive, is like you don't have any aircraft. You don't have any aircraft but your radar is detecting something. So this is false positive. Like that's how you get all these 4 possible combinations.
Okay. Thank you.
Yeah. The metrics are not yet covered in the classes, right? So okay, maybe once that comes, we'll actually discuss on precision and other stuff as well. Maybe it's not the right time to discuss them. Okay, any other questions?
Okay, just I want to ask, like we discussed some other set of questions in these classes, like these assignments, like these questions.
Sorry, I'm not able to hear you clearly.
Okay, I want to ask, like in the tutorials we discussed these some different questions from the course, like this PDF that you are sharing.
No, these questions are basically designed to help you solve your assignments. So they will be more similar to your assignment questions.
Okay.
Like I think I asked you last week, there are some students who are different from the ones who attended last week. Just want to ask the question again. So as discussed in the beginning of this session, the course won't be giving you assignments on like on actually writing some programs or something. But if you are interested, then we can actually take up some problems, small problems, and then maybe we can able to solve. Like you already have access to MATLAB from the course itself. So if you are interested in solving some, maybe I can put up some questions and then we can actually discuss them and solve them during the session. Not immediately, like once the actual ones start, like when the demonstrations actually start in the course, then maybe we can take up some small problems so that you can actually solve. So if you're already familiar with programming, to those of you who are not familiar programming, that wouldn't be actually add any value. It's like you have to first understand that, but still the logics will be fine. We can discuss on the logical part as well. So the last week the consensus was that most of you are familiar with MATLAB and Python. So if that is the case, then maybe we will stick to MATLAB or maybe Python since it is open source and there are already so many libraries available. Yeah, so that's from my end. If you do not have any other questions to ask, please feel free to leave the session. I'll just keep the forum open so that because of the time slot. Yeah, thank you. Yeah, fine then I'll just conclude the session. Thanks for joining, and maybe we'll meet in the next week. Yeah, I'm concluding the session for everyone.